Okay, so I'm doing this is still day two of working on the transformer. It's still like what Thursday, 5:28, and I'm what's it called? Yeah, I now want to focus on. Oops. Yeah, I was just making sure my YouTube is good. I need to debug the transformer because it was really like doing quite bad. I tried to like look into it some and yeah, I don't know. I need to debug it, so I'm gonna actually go to a different run. Yeah, I'll do it on the CPU runtime because I just want to look at the code right now. Yeah, yeah. So I'll go on the CPU runtime right now, and then I'll do the other stuff later. Like I'll run it later. Well, basically, like what is going on? Um, yeah. I think like the main I don't know. There could be a lot of reasons for why this stuff is happening. Um, you can also just go on my GitHub and look at it. Ba-da, 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 ba-da. So what? Dense transformer. Then I have a decoder block. Okay, so this model is actually not too big. The best way to debug this, see if there's any issues. Then we have the trainer and the data loader. All of these are like potential culprits, but I'm less skeptical of the other one. Okay, so so this is dense transformer. It takes in these ints as variables. So L, which is the depth, D is dimension, F is the dimension within MMP, V is what's V? V is our vocabulary. N is the number of key value heads, and H is the dimension of each key value head. Lastly, T is the sequence length. Okay. Linen.compact, when we, yeah, so this is fine. I had some issues with it earlier because of Jupyter Notebook related things. Now I do, init function is linen.initializers.he normal. So we're using he initialization. I haven't looked into this too much. It might be a causing some issue. Um, Initialization problems. I don't know if that's an issue. Okay, that's something to bookmark. Embedding matrix. So I use this notation, right? And it's a V by D matrix. Um, that looks correct. Same with the position matrix. Lastly, then I use a layer norm here because I want to normalize before I go into the rest of the library. I think that makes sense. So the position embedding is also learned, and we use this casting to go to uh, one comma. Then we can just add the two. So we embed it, and then we add the position embedding. That looks valid as long as the embed is valid. Now we do a for loop. We have a bunch of decoder blocks that are declared like so. Oh, my parentheses is closed. Yeah, so I have name, and then you take an X as input. Then I unembed. Okay, of E. Return unembed.unembed. Okay, now we have a decoder block. So this is the other like big thing that takes in a bunch of other things. Um, and it has N, which is number of key value heads, H, which is head, D, and F. Okay, so we create our weight matrices. These are all NDH except for the output weight, which is NHD. That matches my understanding. And the other thing is like none of these have had any errors with Einsum. Like all their errors with Einsum have been resolved. So as type B416. This looks pretty correct, and we're using he normalization again. Is this like the exact same syntax? Yeah. Attention forward. We take the weights and x, we add x. Let's verify. Self-attention. Forward. Takes the weight WQ QKVO x. QKVO x, yeah. Add x. Then we do a layer norm. Then we similarly do these declarations. Init func, and then this shape is df, df, fd. Doesn't look, and then we do a layer norm. Yeah, we just name them, and then we just put the thing in. It looks fine. Okay, self-attention. So this is important. These multiplications for QKV are identical because we're doing MHA, since the sequence lengths are not long enough to have like any KV cache issues. BTD, NDH, BTD, NDH, and then the contracting dimension is D, so that goes away. We're left with BTNH. Use WQ, WK, WV. And yeah, the X is BTD, the other one is NDH. They're all identical, as we confirmed earlier. Now our attention matrix is an einsum, so BTNH, BSNH, and we contract on H. So yeah, we get like a square type of situation for each thing in our batch, and that has like it's basically a mask, right? We want a mask, and then now we're gonna scale it. Attention matrix scaled. Okay, so we get the mask. We divide it by the square root of k dot shape of 3. Now what's k dot shape of 3? Oh, k dot shape of 3 is h. Basically dk, right? Let me just confirm. dk and the dimension of the key inquiry. Okay, yeah. See, it's split. That's what I'm doing here. Okay, now I do a mask. So mask equals Jax numpy dot try. So it's gonna be a lower triangle. Attention matrix scale dot shape of 1. And then we cast it to 1TS1, which is 1TT1 equivalent, right? 1TS1. And what are we doing here? Attention matrix scale. And because T equals S for inputs, that should be fine. So we create this mask. So it's just a diagonal of all ones. And then I changed it to use this mask as a where. So wherever we have this mask, attention matrix scale. So we take this wherever we have this mask, and wherever we don't have this mask, we take a really small number. This is like 0.0000. Wait, no, because I wanted to use like a zero. It was originally going to be 0, right? Why are we using a small number for soft? Because we want to put this through softmax after. Over the estimation. It needs to be negative. Yeah. Wait, if it's like 0, it's like 50%. So like everything gets equal. Okay, is that the issue? I'm just gonna double check the end of this component so we can. This should be negative. Is that true? In the mask tokens get set to large negative numbers before softmax. And I don't want to use the AI overview because it's going to say yes. Why do we use negative infinity for masking and attention? Causal masking. Why setting scores to 0 doesn't. Use negative infinity. Okay. So that's confirmed. That could be the issue, right? I guess that could prevent it from learning. Let me change the runtime. We'll use TPU. No, no, cancel. TPU v5e. So time, so time. Whatever. It's 9 p.m. right now. Probably give myself another hour and a half, and then I'll get early sleep today. Or not early, but I need to wind down before I sleep. Because your resting heart rate before you sleep, it's important for that to be very low apparently. And I think like doing this work, it's not like super intense, but I don't know. Maybe my heart rate is higher when I'm doing work. I assume it is. Connecting. What if I run this? I'm gonna refresh, yeah. But I don't think I made any changes that are worth saving. Yeah, when I was like trying to fix, I didn't find anything. I spent like 30 minutes. Whatever. Um, Connect to Google Drive, CD. Okay, now I need to actually make the change. Open this. What is this nonsense? But I accidentally need to delete this. This is like a test bed. I'm to go delete you. Alright, dance transformer. I was in the components, right? I was in self attention. Instead of 1e negative 10, it should be negative 1e10. Oh, yeah, that's what I was trying to do. And then I was like confused why I didn't do that. Negative 1e10. Really large negative number. Really negative. Yeah, you can say large. Large, yeah. High magnitude negative number. Yeah, the other thing that I was trying to fix was like you can just set an h to equal to d and it's usually it makes sense. But that was not the solution. Initialize the training state. Yeah, this learning rate looks fine. LGT. If I open the terminal, is it gonna disconnect me even faster? Just check. Am I not on the right runtime? I might not be on the right runtime. I am. Huh? But usually something is off. I'm not on the right runtime. It says I'm on this runtime, but I'm not. It's so true. Dun, 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 dun. 在心里听到你的声音，走在走在 Hmm? While I wait for this, just do a little productive thing. Indexing. This is not no views. So funny. Um, your videos. Just want to like edit the descriptions. Okay, looks like this is working fine. That loader. But I haven't like, cause I weirdly enough, uploading it at home like it just didn't work. But then when I went to school and I uploaded it, it uploaded in like 2 seconds. So like whenever I've been on school, I've been pretty busy. But like I'm just gonna go to school and upload everything on one day, and it'll be fine. Edit description. So what did I do? Coding the model and getting confused about Jax. This edit the description. Coding the model, changing the model code to be sensical and work, and also writing the trainer code. There are still some major bugs to be discovered as the model doesn't train. Sounds good. I guess I'll write the description after I achieve whatever result I achieve. Okay. Okay. Model, import trainer, train state because init state. Why do you do this to me? Every time it like every time it disconnects and then reconnects, like you can see like I have a visceral reaction. It's just so frustrating. Okay. I'm sure it's not Google's fault. I've had some Wi-Fi issues, but it's weird that I'm able to like live stream very effectively, and then whenever I use Colab, this happens. Like even when I'm not streaming. So what's my accuracy? Accuracy as if it's random. What it doesn't. Change that. So training, goodbye training. It's gonna show like, oh, do you want to like restart the runtime because it's not interrupted? Never mind. We didn't do that. Okay. Trainer reload. Yeah. Now I should be able to do that. Okay. Just wait. Just wait. Just wait. Just that loader because it's my computer not on charge. Fixed. CPU. Oh, it's using it. Okay, we got some epochs. and it looks like it's not training at all. Like at all, at all. Okay. So let's then like continue with the code. Like this is just not a good sign. Okay, so here's self-attention. We just did that. Dense MLP. Forward method takes in its weights, W1, W2. X embed 1 is the unsum of these two. So you're contracting over D, same here too. Yeah, this looks correct. Gated embedding. So it uses the GLU. Um, GLU example. Jax JS. What is this? Oh, it's no GLU example. Try different. Okay, well, let's just see how they use an activation function. Jax model. Update parameter. Yeah. Yeah, it's a lot of things. Okay. All the time. Build. It's Karis. Yeah, yeah. So yeah, here we use Celia. And they just literally just use it. They don't like name it or anything. How do I think I just do the same. Like and then import Gaia. Because it's just a math function, right? That's why I was not too concerned. This is literally just a math function. So and it would like cause some issue if it wasn't able to gradient descent through there. I don't know. This is something to look out to as well. BTF, BTF, BTF. Because it's just a element-wise product of the two. And you do BTF, FD, BTD, yeah, with the out matrix. Yeah. I don't know if this could be the issue. I don't think it's the issue. Embed, contract over V. This is very, very WX, XW. I don't know what's wrong. I don't think anything's wrong. WX, contract over D, same idea. WX, XW. Is there any issue? Looks like, yeah, the exact same. Trainer. Okay, this is like a big one. Let's start with, let's start with train step. So like this is like the paradigm like we use for training, right? Take a train step, define a, I'm gonna flip that. Training the model. So you define a loss function. No, but this was using n and x. I'm pretty sure this is not using flex. Like they like changed it to, it's like why is this in the Flax repo and it's using N and X? Train state. Okay, so yeah. Here's like part of it. You create did I take an RNG here? Do I take an RNG? Yeah, I do. In shape, learning rate. Shape is just the shape of like the test. Model.init, JMP.zeros, yeah. RNG. Okay. This is like what I do, right? Model.init key test x. And this is just test one. It's like this should not matter what it is. Optimizer. Tx equals objects.atom. I use atom w, but that should not be apply function equals return train state dot train state create. Apply function equals apply. Params equals params. Tx, yeah, this is just keywords, yeah. Model dot apply, right? Jax dot jit model dot apply. I think my call function is already Jax dot, so it should be full. Plus, that wouldn't like be what causes gradients. Stuff. Function, take in the params, and you're gonna use predictions equals model state dot apply function. So here, what do I do? Logits equals state dot apply function, state dot params, batch. And then loss equals to, then we return the mean. We just return the loss. So I return loss and logits. This could be an issue. This definitely could be the issue as well. It's like the way I return this. But the fact that none of the shapes cause the problem is like why I'm not extremely concerned. And also like I copied that part directly from a guide. Gradient function equals value and grad. Loss function. Model dot state dot perhaps. Yeah, state dot perhaps. Model underscore state. Wait, they do value and grad of it. And I define the function with aux and I do it this way. I use state. State equals to apply gradients, grads. And I compute some metrics. This should not be the issue. It could be part of the issue. Okay, so the only weird thing is that like I'm using state dot params here instead of params, but it shouldn't matter because over here we declare the gradient function. Maybe, right? Why don't I check it out? Uh, train stack loss. Okay, Jax value and graph. Value and grad function equals Jax value and grad. This is just a function. You take into the margins. That's how they did it, by the way. Just want to double check. Yeah. Ba-da-da-ba. Data params. So yeah, the main reason I feel funky about this is because data params is here, but the function that this gets applied and the way that like this person say it's like they run it on the function, right? So like how can you take the gradient of a function if you're not using its argument with respect to its arguments? I don't know. Maybe you should just test that. So all that entails is changing this to params. Could lead to any improvement. It's not using params. So it's just this. Meanwhile, we can look for other issues. Um, compute metrics. Yeah, I needed to look into this. Grad function has ox volume grad. It's not running. It's not running. We have like a weird state on it. It's running now. Okay, let's go. Go. Hey, can you teach me how to spooky? It's like some notebook. Yeah, it was this. Okay. Loss is like exploding. What? But why is the training? Even the validation is good. Wait, what? Dude, this is overfitted as heck though. But it's actually learning. Wait, that's like, oh my god. Wait, are you serious? Wait, let me look. Do they use self? Did they state that params or do they not put anything? Like I filled it in wrong because if I was in this class, I would have failed this homework. Train state. But I tried to do this and it was a nested dictionary. So it like led me to use state dot params. I have no clue. Wait, are you serious? Oh my god. Why is it overfitting so much? Is there any like trends in Val? There's a lot of 12s at the end. A lot of wait, what's 12? 12 is space, right? There's 12 equals. Got it. My drive. Code. Jax Transformer. SIC. Hey, I'm so happy. I'm so happy. Dang. Hey, okay. How do I see? What was I looking at? I lost my train. Wait, I was looking for like what, 12 points. If it's space, like I guess it could make sense in theory. It is space, yeah. So these are all like valid numbers. Why is it putting a space in the middle? It doesn't do that on any of the trains. So you should never go to space and then not go to space. And the but the loss is what's the train loss? Wait, train loss is so low. Overfitting because what? After seeing 1,000, like it hasn't seen all 1,000,000 yet. So there's no way like it's like perfectly overfitted at this stage to get 99% accuracy instantly. This train's super fast by the way. It's just like maybe it's too good to like or maybe my data set is too easy or something like that. But what? Is it 3-digit addition or 4-digit addition? Three up to 3-digit numbers. Okay, I don't know. But anyway, if these laws are like out of control for validation, I would say that points to like an error in the validation step. So what do I do? Okay, there's a lot of ways this could go wrong. Okay, so I do a batch heading. Batch of B, everything up to the last four, then D. No, then B, right? I then create zeros with those B, comma 4, comma V. Yeah, that's fine. I concatenate that. So now I have zeros at the end. Next, I get the logits. I think this is fine because I'm not doing a gradient. I don't know. Flight function is just forward, right? Validation array. Is that how you do a forward? I assume so because it's getting 50%. Like that can't be the issue. How is there like such a no? Like the loss is like so weird. What? How are you getting such a okay. Like there must be like a train val mismatch in how the data is presented because this is like worse than random, right? Yet simultaneously the accuracy is like not even that bad. How is it on? Okay, on first digit it's like wait no. This is like yeah. It gets 100% on the first digit. And then second digit. Okay, so it seems like it's bad at the rollouts because how about here? Well, it doesn't roll out here. So you can't tell it. It's getting 99%, like 100% accuracy basically, right? So how can you get 40% accuracy and everything is right on the first one? Like if everything is right on the first one, conditioned on that, everything should be right on the second one. Okay. Validation array. Okay, well this is like some slicing logic. I slice the specific row, which is the fourth from last row, or the third from last, or the second from last, or the first from last. -1 would be the last, right? So last, second, third, fourth. Okay. I set it equal to this because every logit computes like what's like what it would be shifted over what. Then the validation array, and then I continue onward. And why is the rollout bad? And then I compute metric. And over here, this is just like the normal way, right? The other weird thing I do is I shift it by one, but that wouldn't make sense with why the first one is always good. So it has to be like the rollout. I can like always just print out like what it looks like. Print. That's right. Print. No, no, I want val array. Uh, so we'll print before every. Ba-dum-ba-bum. I'm so excited that the training is working, but I don't know. This is really weird. It's like what I'm looking for is like some weird thing. Like you know the last slot, but the last five slots, the first four of the last five. Is there more? I don't know if there's more depth to say that. Those, it's not running yet. Stop it. Jax.debug.print. Yeah. It should work. Okay, let's try one more time. So we'll see like the first row and it's gonna be some complete nonsense. Um we care about the let's cut one after 1,000 probably. I don't know how much it was after 1,000 accuracy. How many parameters do I have? Um that's like 200, like no, 2 million. Yeah. The budget is 10 million. Okay. What? Why is it all zeros? Wait, no. Zero, zero. And the last few is like the logics. And then they look softmax. It's like the first one is very clear. Oh wait, no, it can be more than one. Well, no, I think this is the issue. Wait, why are like if this is getting passed into the model, it doesn't make sense at all. It actually doesn't make sense at all for a rollout. I need to do an argmax inside. This is probably the issue. Um, I'm gonna do it like this. JNP dot arg x axis equals to -1. I'm gonna try one more time. That might not. That might like errors. I have no clue. Phew. No import error. Okay, one thing I need to probably do is like increase the print. I need to like log like those like train loss. Oh, access defaults and everything, so that's fine. Yeah, but yeah, that's the issue. Cause yeah. Mm. Maybe that's fixed. We'll check the print. It should be all ones and zeros now. And because the input is always ones and zeros, so if the model sees anything other than also the logits are not like they're like way out of range too. So like obviously the rollout would suck after the first token. If anything, hmm. So at random the accuracy would be like 6%, right? I guess the model's picked up some bias, but okay. Well, this is the literal first one, right? Accuracy sucks. Is that yeah? That's okay. It's all one and zero. Okay, let's get to 1,000. Reconnect. No, reconnect it. Ball accuracy. What's the loss? What's the loss? What was it after one up? I think the loss is high because it calculates loss on logics and then it does the arc nuts like normally during training. But then like during validation, we don't see that. But the accuracy is 99. That's like what that's like everything I care about. Okay. Okay. Alright, so the next thing to do is probably set up like a couple of it trains super fast now. Okay, I need to set up a couple of small ablations and also before I do that I need to do a little bit of metric tracking so like I get those nice like loss curves. I guess since I want to see training and validation next to each other, it would be like accuracy curves. So it would go up. That's fine. Um because the runtime for things is gonna be so short. Um I need to have metric storage though. That's basically what I need. Um no, like 1000 is fine for bus. Something something. So what I'll do is I will I need to store metrics. Yeah. How do I do this in a nice way and then plot it? I can return it, right? Accuracies equals to this. And then five mod zero. Now it's gonna print those metrics. Also, oh, I want to stop printing out like these entire matrices. We do not need to be doing that anymore. Print? Oh, because I added it to the metrics. Gotta um, accuracies. Accuracies. The append, and then we'll have this if they'll say what step I I don't even know if this is the proper way. I think this is the proper way to make good dictation. I should step I uh val accuracy accuracy train accuracy train metrics of accuracy. Okay, that looks good. Okay, how to graph a list of bits Python. Python multiple lines. Okay, I'm literally just gonna copy this. Yeah, it's fine. Accuracies. P dot data frame x. EF dot set step. Yeah, that's literally what I need. Okay. And this should just, it's currently using 100 as a step set. I mean, it might be too, like, maybe too much training still. Like, smaller batch size, something like that. This is annoying how long it takes at the beginning. It's just the JIT compiler. I have JIT. It's only been like an hour. I feel like I've made so much progress. Yeah. Okay. I'm like, actually double check. No, I can't be like getting cocky. What if did I check? I think I did. I did see it on my like, YouTube on my computer. Yeah, yeah, I'm live. Yeah, I see it. What I did recently. Wait, that's so good. Yeah. Okay, we actually get to see like. All right. Wow. And then it just hits 99. Interesting. No numerical data to plot. These are arrays. Floats. Okay, let's try one more time. Eh, put it in the wrong. It's better. Boom, 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 boom. Please don't fail. I mean, this will pass. Oh, yeah, I could log like every like 50 instead. Um, I wonder if there's a way like this is something I was thinking about earlier. Is like because there's like only 1% are like 2-digit plus 2-digit multiplication. I assume the reason I get stuck at 9. So I maybe you should be doing some data augmentation such that I get to 100% accuracy faster. Um, yeah. Is it done? Okay. So there's basically no train valve difference. See, I want to see if I can. I don't know, but that might delay like the spike, right? Like if I was like doing a scaling study, I would just cut it off here. Okay, I've decided. Honestly, like the data format is like cool, but it doesn't. because there's so few of them, it doesn't actually hurt the accuracy, and it just like makes it like weirder for the model to learn. So I'm gonna change the data format. Executive decision. Let's go with that. Data set. Okay. If prefix length is, how do I do this? Be no more space padding. Um, ISTR equals to STR of I, JSTR equals to J, sum STR equals to STR of I plus J. If length of ISTR is less than 3, I'll do this. ISTR equals to 0 plus ISTR. I'll do the same for JSTR. Less than 4 for some STR, right? Because yeah. So now we're guaranteed to have these lengths. So I should just go to get rid of these. Current prefix equals to a string of I SCR plus J SCR. Current stuff yes, sums. It's fine. I'll just keep the current. This changes a lot, but I don't know. Let's do this then. Import data set. Data set dot save addition CSV. Okay. Now I'll just download it. Let me take a look. Basically, everything is zero padded. What happens to like the other ones? Yeah, everything is zero padded. These are all the proper length. It looks good. LGTM. Okay. So now I need to do the data loading and everything again. There's no space now. Is that a problem? Is that gonna get me in trouble? No, I should be fine. I don't know, it might be too easy for you. I'm gonna screenshot this. If it's like too easy, we can revert. Like control Z. Like make the task visible for no usage. Let me check the task description. Like, how do I differentiate off the job? What? Oh no, because I logged it way more often. It hit one, yeah. I was right. Like it avoids the data like augmentation issue. But let me make a note. What about 500 steps? Oh no, if I'm gonna be honest. This is like actually good. Like actually like it learns the full thing. Oh, where is it? I just opened it. You hard coded to accept like so it accepts space, but we don't use space. First iteration, use space to add after equals side equal like this. Second, hard training. Model gets to 99% and takes a while for the last percent. This is because examples with padding, for example, two-digit number addition, are rare. Takes is 1% of data set. Could be solved with data augmentation, but it's not really a lever. Lever is a ChatGPT type of word. Right? I mean, I'm writing this live, but that's pretty funny. I don't want to use that word because I don't like ChatGPT writing. But I know it's a ChatGPT. It's not really a like. This could be solved with data augmentation, but it's not really a um variable I want to add. I want to focus on the scale. I decided to just zero pad 100s, 10s, 1000s, 100s, tens digits. So example 0 for 15 plus 0 equals to 79 equals to 4, 3, whatever. Earns 99% of data. It now just learns. Yeah. And the reason I'm writing this is because like he said to use space, but now we no longer have a use for space. It's just like a more efficient thing. And yeah, okay. That's fine. Okay. Cool, cool. So now I wanna look into like the chinchilla law stuff. I can do that on my own time though. Mixture of experts. Do I want to implement that today? No. I think today all I want to do is try out a couple of different architectures. Uh, I don't think I'm gonna be training like 100 models in parallel, so actually let me see. Chinchilla scaling law. I might be training 100 models in parallel. How to train models in parallel, Jax. Jax of VMAP. Okay. Map. I want to ask a question about this. I guess like the models are gonna have different shapes. So it might be fine to just do like a for loop. Yeah, it's fine. Okay. Mhm. Models equals. Wait, also, why are there so many like different lines? Like, what's going on? Training, like, it's gonna get down to 0 though. I'm sure there's a link. I need to read the original paper. Approach 1. So if it takes more parameters, you need more flops? In a fixed flops budget. Okay. Oh, that is an interesting question. So the issue here is like, ISO flop profiles. Right. So I won't be able to get these because my losses will all be 0. Basically what I will care about is like time to 0, right? That's fine. Models equals to, I'm just gonna try with like 8, 7, 6, and 5 ways. And we'll also go for like it worked. Okay. Mm. Modeling models. I guess those two. Um, basically this, right? This, no, I just do. Well, and obviously there's like learning rate adjustments that I could do. Like I could increase the learning rate by an order of magnitude for this list. Yeah, worry about the task. It seems really easy for models of this size. Like I can do this speed up thing, but the chinchilla loss, I have a thing to look out for. Okay, that's the first model. And right now, I'm not concerned about like making the graphs look pretty or like labeling things. Like it's okay. Um, so likely done with this training. Now on to the next one. What? That's not good. You just failed. Yeah, that's great. Is it because the prints? I doubt it. I don't really need a TQD on that since it's so fast. I can get rid of that if that's the problem. Why? You stop exactly at 400. That's suspicious. No, it hasn't stopped at exactly. Not at 100. I'll give myself 10 more minutes to die. I really need to find a solution to this. If it's just like this is the message. It's just with no way of knowing why the runtime disconnects. I just have to assume it's like my Wi-Fi. The stream is going fine. Well, we're 1 minute in and we have yet to print anything, which is concerning. I was just waiting. Wait, I also like messed this up. Yeah, that's the issue. Ba-da-da-da-da-da. Why does it take so long at the beginning? I've just been accepting this, but this is the main, like the main time pass is by far just the beginning. Um, what are we doing? And trainer.train. Uh, trainer.train. What do we do? We just run. We just get going right away. So this is the this has to be Jax.jit. It just has to be. Mm, that's the first model plan. Yeah, I mean the thing is the shapes do change, right? The shape of batch chains. And like yeah, oh, because it goes through everything. I guess I have to accept it. Important. Is it? I made it print that every 200. Oh, that's still a lot. It's not, wait, that doesn't make sense at all. Oh, Valentine. Hmm. I mean, I guess I do have like a loss. Lot zero. Hmm. Did it take long enough? I don't know. It looks the same to me. It's exactly the same to me. We're just over parameterized for the task is my main takeaway for right now. It's even faster. It's also possible learning rate, param count, interactions are having a large part here as well. Those are all things I need to sweep. Fantastic. For that in the chinchilla one. Learning. Hmm. You set the learning rate schedule to approximately match the number of training tokens. That's spicy. Sequences. And each of these is changing the cycle length. So you always want the cycle length. They find is yeah. I'm not using anything cosine because again, like there's no overfitting going on here. Isn't that all? Didn't I only train 4 models? What are you waiting for? It's 3. It looks like 4. Maybe it could also be 3. What? So here's how they differ. Like this one gets it before 400. They all get it. This one gets it even further before. Okay, so the small models converge better, but that's likely an effect of learning rate. So I'll need to tune the learning rate and find like a suitable law for like that by the task such that we can, you know, actually like gain some info of this. Interesting. Yeah. Okay, that's gonna be all.